Okay, so guys, now this is the video on section 2.6. So what we're going to cover is what is free fall. So lesson outcomes is this. In this lesson, by end of lesson, students should be able to state that the acceleration due to free fall body near Earth is constant, and it is approximately 10 meter per second square. So acceleration due to free fall, sometimes they denote it by g, right? Denote it by g, and g is 10 meter per second square. Now this is said, we call it acceleration of free fall, okay, which is what you experience when a ping pong ball falls down, or when you throw up the ping pong ball, it slows down, right? It is due to the force of gravity. So another way of saying it is also acceleration due to gravity. Okay, now this is something that you need to know. It's a very simple thing because you have already been looking at some of the examples. So let's look at this. Okay, so all objects, irrespective of mass, will fall freely under Earth's gravitational force in absence of air resistance. So actually, there's a very popular YouTube video, right? In the interest of time, I can't show you this because your WA is going to be very soon. But when it is over, right, you can actually see that they actually drop a steel ball and a feather, right, down a vacuum. Then you realize that surprisingly, right, in the absence of air resistance, and it's purely vacuum, you find that both objects, right, be it the steel ball or the feather, will actually reach the floor at the same time. So without air resistance, a body in free fall experiences an acceleration of g, which is due to gravity. In other words, free fall. So g is the acceleration due to gravity, right, of free fall. So what happens is that initially the velocity will be 0, which is here. I think better use a different color. Okay, you start off at 0, but your velocity will increase steadily with constant acceleration. Okay, now this constant acceleration is what you see on the graph here. You find that it accelerates, right? In the first second, it accelerates by 10. In the first second, from 0, it reaches 10 meters per second. In the second, 20 meters per second. Third, 30 meters per second. Fourth, 40. Fifth, 50. Sixth, 60. 7 will be 70 meters per second. Now 70 meters per second is actually no joke, right? If you want to convert, let's say at the end of 7 seconds, right, is 70 meters per second. Now sometimes you may need to convert this, right? If I convert this to kilometers per hour, right, it's actually 70 meter divided by 1 second. Now if I were to take a calculator and calculate, right, 1 second is 1 divided by 3600 of an hour, and 70 meters is actually 70 divided by 1000 meters to form kilometer. Okay, so that being the case, you have 70 kilometer divided by 1000, because 1000 meters make 1 kilometer, times, this is not 6, it's actually h. Okay, so it's actually h as in hour, right? When you multiply, it's actually 3600 divided by h, right? So what you have is 70 times 3600 divided by 1000 is actually 252 kilometers per hour, or 252 km hour to power minus 1. So you can imagine, right, if you have an object that drops for 7 seconds, right, by the time it reaches 7 seconds, the speed is an alarming 252 kilometers per hour. Now, if you want to know how fast this is, right, do you remember the Ferrari that crashed the taxi at Bugis, killing the taxi driver? It was traveling at 180 kilometers per hour. So, there you have it. Can you imagine, right, if let's say any person were to accidentally drop from a tall building and is traveling for 7 seconds, by the time he reached the floor at the 7 second, the speed of his impact is 252 kilometers per hour. So what do you think of the chances of the person surviving? It's almost close to zero. Even if he can survive, he probably will have a lot of broken bones. So in 7 seconds, you can reach this kind of speed. So in this context, right, the acceleration due to free fall, it looks like something very innocent. G is 10 meter per second square. Okay, but it's actually no joke. So that's why when you're at very great heights, right, always be very careful, because if any object, it can be a rock, it can be human being or anything, were to free fall, right, for 7 seconds, you can imagine how fast it can go. So let's say if there's air resistance, you'll find the rock will fall faster compared to feather, because the feather will be floating. But if let's say you remove the vacuum, right, you remove air from this container, right, such that it's a vacuum, right, you find that both objects will reach the floor at the same time. Okay, so case in point, right, it's not just theory that you need to do this, right, but sometimes you have examples like this that you need to solve. Now, figure 2.21 shows a ball released from rest at a height of 0.8 meters. Okay, this is very much like the example of the ping pong ball, right? Okay, so now it's released from a height of 0.8 meter. Time taken for floor to reach the ground is 0.4 second. So that means it starts off at u equals to 0. Height is 0.8 meter. Time is 0.4 seconds. So using graphical method, calculate acceleration due to gravity. So let's solve using graphical method, right? So area under graph is distance traveled by the ball. Okay, if you remember, we covered this in the summary before. So as you know, acceleration due to gravity, right, the acceleration is uniform. Okay, now you know that in 0.4 seconds it covered a distance of 0.8 meters. So area is distance traveled by ball is half times base times height. So in this case, this is B and this is H, right? So this height actually represents the velocity, right? So the distance traveled by the ball is half times 0.4 times V. Okay, I don't think I want to confuse you, right? So you have 0.4 divided by 2 is 0.2 V meters. Okay, but as you know, the distance traveled by ball is 0.8 meter. So when you substitute 0.8 into 0.2 V, V will therefore be 4 meters per second. Now, if you want to know what's the acceleration of the ball, you use A equals to V minus U divided by T. So what you have is actually 4 minus 0 divided by 0.4 is 10 meter per second square. So that being the case, right, this is the example. So there are times where you need to use some of this formula, right? But if you don't practice, you have no exposure to it. So you will have problems doing this, right? So please be mindful. So with that, I come to the end of the lesson. So I hope you really should try the questions, right? I think minimally you should try the LR worksheet followed by the HR. HR and LR actually there are overlaps, right? So I think you try the LR first. For your context, right, I think just focus on the short question and answer, because if you know how to do that, then at least you're more or less prepared for your WA. So with that, I come to the end of this chapter 2. I hope you play the videos over and over again until you understand what I'm teaching you, and hopefully this will help you prepare for your WA. Thank you.